What else do you guys know about? You guys know about things? Tell me what you know about. What do you know about, like, what are good with points? What do you guys...
Equations.
Oh yeah, there's a distance formula, right? That's like the second thing you learned about points? Okay, so don't worry, it's still the second thing you're gonna learn. Okay? So what was the essence of the distance formula in 2 dimensions? Yeah, Pythagorean theorem, right? So, yeah, triangle with labels, right? A, B, and C. Then what's the Pythagorean theorem say? Okay, so A squared plus B squared C squared. What's important about the triangle? It needs to be a right triangle, and yes, it has to be the long side, right? Okay. The key to the distance formula in 3 dimensions is the exact same thing. You guys want to see if you can, as a group, build the distance formula on this thing? Okay, so here at random is a point. Which is hard to see in my camera. So
A
there
squared
at random
plus
is
B
a
squared
point.
plus C squared equals.
Oh, so in cylindrical it'd be really easy, right?
Yeah.
You guys all see that? So, can you point at the bits of the triangle you're seeing?
Yeah, the distance from the origin to the base of the pipe is r, radius,
Okay.
and then z is just the height of the pipe.
Okay.
So like a distance would be r squared plus b squared equals distance squared.
Yeah, that seems awesome. So, in cylindrical, we can say that distance squared is r squared plus b squared. Right? Okay, so how about in regular Cartesian? Well, I guess I should give you the easy one too. Which one's easier, Cartesian or spherical?
Spherical.
Spherical's easier.
Spherical. What's the answer in spherical? How
Rho.
far is the point from 0?
Rho.
Rho. Right?
Yeah.
Awesome. I didn't even need to square both sides on that one, or use this crap, right? It just is that distance, because that's how it's defined. So how about in Cartesian?
X squared plus y squared plus c squared
Why?
equals the distance squared. Because the distance in standard 2 dimensions is x squared plus y squared. Add another dimension into that because they're at a 90.
Can you show me that on the triangle?
Yeah.
What am I doing? Here. Here's a piece. And here's a piece. You're standing in front of the camera. Push. Alright, so where's the triangle you're saying about radius?
So here's your first triangle ish, and it's at a 90.
You guys all see that? We went out some in the x and out some in the y.
So your x squared plus y squared equals r squared, or distance squared.
And then
you have your other triangle with this one and the height at a 90, making your other diagonal. So you have x squared plus c squared plus y, or x and y squared plus c squared equals your third one.
you guys all see that? So there's 2 triangles, right? That you're applying the Pythagorean theorem to. There's one that's...
Rambles.
You did a good job picking a classroom with roses. So there's one on the floor, right, in the xy plane. That tells us about r squared. And then there's one in the, really kind of along the z-axis, right? Perpendicular to the xy plane, anyway. right, telling us about that distance squared in terms of the radius and c. So our moral of this story is that the distance formula for Cartesian is that distance squared is
X. I don't know, like x squared plus y squared plus c squared.
x squared plus y squared plus c squared. So what's the difference between 2 dimensions and 3?
Another dimension.
Another variable.
Really kind of the same thing, right? There's just one more thing. You guys see that? And it's really cool that it acts that way because it makes memorizing this really easy. Cool. Did anybody take linear algebra?
Attempted.
Okay, so how long's a vector? You guys remember that formula? Yeah, like a, yeah, what's the magnitude of a vector?
The product of itself.
Uh-huh. Which boils down to you take all the coordinates, square them, and add them together.
Right,
Yeah.
This thing keeps holding in distances or in dimensions past 3. It's still true. You just add the next coordinate squared, add the next coordinate after that squared. Cool? All right.